This is lesson 2 of the Year 10 chemistry topic, looking at bonds between atoms. So I'm going to talk about bonds in this video. So bonds are formed by the electrons in an atom. I should specify chemical bonds. Okay, so chemistry is all about electrons. Okay, electrons doing things. That's what distinguishes chemistry from, let's say, nuclear physics, nuclear science. Nuclear physics involves primarily the atomic nucleus, whereas chemistry solely relies on electrons. And bonds can be formed in different ways. Here are 3 ways that bonds can form in an atom. So one way is through what's called a covalent bond. So a covalent bond is formed basically when outer shell electrons in 2 non-metal atoms are shared. Okay, so occurs when, and they've got a fancy name, these outer electrons, valence electrons. Okay, valence electrons means outermost electrons. Valence electrons are shared. The key word here is shared. They're shared between 2 or more non-metal atoms. Okay, the most simplest example I'd say is that of hydrogen. So hydrogen is the simplest of all elements. It's the first element on the periodic table. It's got an atomic number of 1, an atomic mass of 1. Hydrogen has 1 proton and 1 electron. Okay, so suppose you have 2 hydrogen atoms. What would these 2 guys like to do? Well, they'd like to, the goal of any atom is to have a full outer shell, okay, because atoms want to be stable. Okay, hydrogen is highly reactive in this state. Okay, it's only got 1 electron. So what it wants to do is to have a full outer shell. So this is the first shell away from the nucleus, can only hold 2 electrons. And each hydrogen atom here in this case, that's what the H stands for, hydrogen, only has 1 outer shell electron. So each one wants to have 2. And the way to do that is to bring them together. Okay, these 2 dots here, these are the valence electrons. These are the outermost electrons. Okay, and that way they'll be much happier. So here's a plus, here's a proton. It'll look something like this, roughly. Okay, so both electrons are shared between both hydrogen atoms. Okay, they've both agreed that let's share electrons. And so they're now both happy. They've got a full outer shell, right? And so this is written as H with a subscript 2. Okay, this is a hydrogen molecule. It's a hydrogen molecule. So hydrogen is a non-metal, and so therefore it involves covalent bonding. So having talked about valence electrons, let's now get into the idea of valency. Okay, there's an idea in chemistry called valency. Valency is actually a Latin word. It's a Latin word for to be strong or strength, okay? It's basically, there's different ways to define this. It's the strength an element has to combine. Okay, or the combining power of an element. And the periodic table actually is a great way to determine the valency of each element. Okay, looking at the groups or periods. So, the groups or columns. So a group is another word for column on the periodic table. So group number tells you the valency of an element. I'm not going to draw it. It'll get too messy. But there's basically 8 groups on the periodic table. So there's group 1. These are known as the alkali metals. Okay, examples are lithium, Li, sodium, Na, potassium, K. Group 2, these are called the alkaline earth metals. Examples include magnesium, Mg, calcium, Ca, strontium, Sr. Then you've got the transition metals. They're not really a group because they make up most of the periodic table. Transition metals, okay, for example, Okay, so most of the elements on the periodic table are metals, right? These include things like gold, Au, silver, Ag, copper, Cu, ... You've got group 3. This includes elements like boron, B, aluminium, Al, gallium, Ga. You've got group 4. Okay, and these include carbon, silicon, germanium. Group 5. Okay, so these are now, we're getting into the non-metals now of the periodic table. Group 5, these consist of nitrogen, phosphorus, arsenic. Group 6, these consist of oxygen, sulfur, selenium. Group 7, they've got a name, they're called the halogens. These are highly reactive non-metals. Examples include fluorine, fluorine, chlorine, bromine. And the last group, so there's 7 groups on the periodic table. These are called the noble gases. These include helium, neon, argon. So each of these groups has an associated valency with it. It's got a number, okay, which dictates the combining power of an element, okay, the strength, if you wish, the combining power. So the metals, let's start with group 1, use red. Group 1 has a valency of +1. I'll explain this in just a moment. Group 2 has a valency of +2. The transition metals, this really depends. Could be +2 at times, could be +3. It really depends on the metal. It's because these metals, they've got weird orbits. Okay, when you get into deep chemistry, atomic physics, you look at orbits. It's to do with the arrangement of electrons. Group 3 has a charge of +3. Group 4, okay, now we're getting into the non-metals. Let's put a line here. -4 or +4. Group 5 is -3. Group 6 is -2. Group 7 is -1. And group 8 is 0. Let me explain what this all means. So let's take the case of lithium. It's actually hydrogen. Okay, even hydrogen's got, I should mention hydrogen has a valency of +1. Hydrogen, let's draw a hydrogen atom here. Plus, okay, proton, one electron. Hydrogen would like to typically give away its electron. Okay, and in doing so, you're left with 1 proton. Okay, so atoms, if you recall, they're neutral, generally speaking. The atoms that we are familiar with from everyday life, atoms that make up our pens, our tables, our papers, they're neutral, right? Unless you, let's say, rub your feet on carpet and then touch a doorknob, you experience a zap. Okay, that's because atoms are now becoming charged. But here, hydrogen has a valency of +1. Now, in other words, the overall charge is now +1. Okay, or you can think of it as the hydrogen has lost an electron. That's where the +1 comes from. Similarly, alkaline earth metals, they tend to give away 2 electrons. Okay, transition metals, same thing. They tend to give away 2 or 3 electrons. Group 3 as well. Getting into group 4, 5, 6, and so on. The non-metals. Let's take group 5. So non-metals tend to, let me write it down here. Non-metals like to gain electrons. That's the idea. And metals like to lose electrons. Okay, so for nitrogen, phosphorus, etc., they would like to gain 3 electrons. Right, that's where the minus sign comes in, because they're becoming more negative. Right, group 6, they want to gain 2 electrons. Group 8, the noble gases, these are stable. They've got a stable outer shell. They've got a complete set of valence electrons, so therefore they've got a valency of 0. They don't combine at all. They're unreactive, highly unreactive. So helium, for example, exists just as an atom. You can't make molecules out of helium. It only exists as atoms, as an atomic element. And that's how valency works. So I'm going to get into now another type of bonding. I'm now going to talk about the ionic bond. So unlike a covalent bond, an ionic bond occurs between a metal and non-metal atom, okay? It's basically when an atom gains or loses an electron, or it could be more than one electron, due to electrostatic attraction between a metal and non-metal. I should mention ion. Okay, it's another form of chemical bonding. The most simplest example I can give is that of sodium chloride. Sodium chloride is another fancy way of saying table salt. Here's one of the marvels of chemistry. Sodium on its own is highly reactive, very dangerous. Even if you just put sodium in water, it can cause an explosion, depending on how much sodium you put in. Chlorine is highly poisonous, highly toxic when inhaled. But when you put the two together, you'll get a harmless compound that's actually essential for life, essential for the biochemistry of living things, amazingly. So I'm not going to draw the atoms completely. I'm just going to draw, so I'll write Na. Let's suppose I've drawn all the electrons. Okay, sodium, Na, has 1 valence electron. Chlorine has 7 valence electrons, Cl. When you combine them, what happens is the sodium will give its electron to the chlorine atom, provided they can bond, okay? And you'll get this, NaCl. Okay, you get a positively charged an overall positively charged sodium. This is called a sodium ion. And you get a negatively charged chlorine ion. Ion is another way of saying charged atom. Right? And ionic bonds, they tend to form compounds that are basically crystals. So NaCl, you get this repetitive, a crystal's consists of this repetitive pattern of particles, right? Of atoms, or ions in this case. So here's what a crystal of salt would look like under a microscope. Sure you get the idea. And that continues on, okay? So that's an ion. An ion is a charged atom. Ionic bonding results in the formation of ions. And the third and last chemical bond I'm going to be talking about is a metallic bond. Probably the most simplest to visualize. Metallic bond is basically formed due to the sharing of electrons among, I'm going to get a bit fancy here, among a lattice of positively charged metal ions. What does this mean? Well, if you were to take a copper wire, so copper makes up most of our electrical wiring, you would zoom in, you would find positively charged nuclei, right? So remember, nuclei are positively charged. They've got an overall charge of plus, because neutrons are neutral. And you would see electrons not latched onto the nuclei, but rather roaming freely. And if you apply, let's say, a voltage, a force, you can get the electrons moving a certain way. So these dots are electrons. These electrons have a fancy name. These are called delocalized valence electrons. So in other words, all the electrons are being shared amongst all of these copper ions, right? Delocalized means they're not attached. So think of your local supermarket. Local means it's nearby. The electrons aren't local in this case. They're delocalized. So they're roaming freely through the copper wire. And they're the different types of chemical bonds.